Whoops, my fault. Number 12. And watch closely because there's going to be definitely a problem just like this on the final. Let me close this silly window. There we go. So number 12 says to solve 2x minus 3y equals -9 and 5x. My iPad froze in. This is getting frustrating. 5x minus 4y. I'm so mad at Apple because they were supposed to come out with iPads in March, but now they're coming out with iPads in May, on May 7th. And that's going to be so too late for us. So 2x minus 3y equals -9. 5x minus 4y equals 2, right? So we have to solve that. So the critical thing is to know what the common multiple is of 2 and 5, because those are the x's, or what the common multiple is of 3 and 4, which is the y's. So which is a smaller, what's the common multiple of 2 and 5? The smallest number of the 2 and 5 both go into 10, right? And then what's the smallest number of 3 and 4 both go into? So which is easier and smaller, 10 or 12? 10 is smaller and easier. So we're going to go with the x's because those have a common multiple that is easier. So what we need to do is to get the x's to become a common multiple, which is 10. So what do I do to the first x to make it become 10x instead of 2x? What do I have to multiply times 2 to make 2 become 10? 5, right? So I'm going to multiply the top equation by 5. Now that was pretty straightforward. So make sure you practice this and learn this really well. And then you need to make the bottom x, however, not become 10x. You need to make it become -10x. It has to be the exact opposite of the common multiple. So how do you make 5x become, well, first of all, how do you make 5x become 10x? By 2, right? So if you multiply it by -2, it'll make the 5x become -10, right? So that's the important process, is to look at the letters, figure out whether the x or the y has the smallest common multiple. Whichever one has a smaller common multiple, which in this case is 10x, make both x's become that common multiple, and then the opposite of that common multiple. Well, and then go ahead and let's do it. So after deciding what to do, the next thing is to actually do it. So what is 2x times 5? It is 10x, right? So now, by the way, to keep this problem together, sometimes people write a little thing like that in front of it. So I'm going to do that. So the top line, 2x times 5 is 10x. Then -3y times 5, what is that? That's -15y. -9 times 5 is -45. Then go to the next line. And the next line we're going to do -2 times that whole line. So what is -2 times 5x? It makes -10x. And then what is -2 times -4y? It is +8y. And then what is 2 times -2? It is -4. Perfect. Now we're ready to add the equations together. 10x plus -10x is nothing. -15y plus 8y is -7y. So it's going to be -7y. And I just recycled that little spot that was on the screen. Then -45 plus -4 is what? That's -49, right? Now I'm ready to solve the next step. What's the next step? Divide both sides by -7, right? And then your y by itself equals +7, right? We got y by itself and we got the solution for y. However, this problem is only halfway done at this point because I don't know x. So what if you were escaping from the communists and you had the secret key and you unlocked one concrete door, but you didn't have the key for the other concrete door, and so you got stuck? We need the key. We need to know what x is as well, right? So we have to take this value of y, plug it into any equation that has a y and an x in it, and then use that to solve for the x. You can use this equation, this equation, this equation, or that equation. But I like to use the smallest one. So I'm going to go with this. Which one is the smallest? Maybe the second one. I'm going to go with 5x minus 4y equals 2. So I'm going to write that down again. 5x minus 4y equals 2, except I'm going to erase the y, and I'll plug into the y the secret special key that the top secret spies found to help us escape from the communists. So what is negative 4 times 7? Negative 28 equals 2. And then add 28 to both sides. So we'll get 30. And then we got 5x equals 30. What's the next step to get x by itself? Divide by 5. X equals 6. So boom, we solved it, and that's all you have to do. Just solve for y, solve for x. Now on the computer homework, you're supposed to put your answers together as an ordered pair. But on the final, I'm just going to just grade the work, whether you solved it right. So if you got y and x, then I'm going to give you full credit for it. But the answer on the computer, just to remember, was you're supposed to put x first and then y, which represents the point where the graphs cross each other on the graph. So there we go. That's your number 13 now. How many of you like to go boating? Anybody like to go boating? One time I got really lucky and I got to go boating on a boat that the congressman was renting at Beach Lake, but it was kind of cool, but it wasn't really like my boat. So I basically just sat there and just kind of watched the water go by. So boat's crew rode 16 miles downstream with the current. So who knows the secret formula for solving distance and travel problems? That's called rate times time equals distance, right? Rate times time equals distance. There we go. Then it says that, first of all, it says they rode 16 miles downstream. That's the distance, right? And then it says they rode with the current. So if you're rowing with the current, then the speed you're traveling is equal to the speed of the boat plus the speed of the current. If you're traveling with the current, the rate is equal to the speed of the boat plus the speed of the current. And then it says the time was 2 hours. So the first part of the problem tells you it takes 2 hours of time to travel 16 miles of distance with the rate of b plus c. The next part of the problem says that you have, let me write a line to do the next half. The next part of the problem says that you have going against the current. So if you're traveling against the current, then what rate are you traveling? If you're going against the current, then the rate you're traveling is the speed of the boat minus the speed of the current. And it says that it takes 4 hours. So if you have logical thinking, that means it must be the boat must be traveling twice as fast as the current. Is that right? Not necessarily, because you can't always necessarily just use ordinary logic in math, because you have to solve it. Because if you wouldn't need math anymore. So my guess maybe is the boat's traveling twice as fast as the current, but I could be wrong though. So boat minus current times 4 equals, and it travels the same distance of 16 miles, the same exact distance, 16. So those are my two equations, right? Boat plus current times 2 hours of time equals 16 miles. Boat minus current times 4 hours of time equals 16 miles. Now, in order to do it, you always have to remember your first step is to simplify out the greatest common factor. So if you see something on both sides of the equation that can be divided by, then you go ahead and do it. So in the first equation, both sides are divisible by 2, right? And on the second equation, both sides are divisible by 4. So if I divide that side by 2, I'm going to get boat plus current by itself equals 8, right? And on this side, you'll get the boat minus the current equals 4. Now that's a little hard to see, so let me go to a darker color. So I'm going to write this again. Boat plus the current equals 8, and boat minus the current equals 4. Now notice that this time I actually put them above each other, because what I'm going to do next is I'm going to add them together. So if I add those together, you'll get, what's boat plus boat? 2 boats. So if you got extra rich, you could have 2 boats. And then what's current plus negative current? Nothing, right? What's 8 plus 4? 12. And then divide by 2. You know what? If you went to college when you were 8, you graduate when you were 12. If it took you 4 years, that'd be cool. So the boat is traveling at a rate of 6. So do you think that the boat's traveling twice as fast as the current and the current is traveling at a rate of 3? What do you think? I have no idea. But let's go. How do we find out for sure, though? We know the boat is traveling at a speed of 6 miles per hour. How do we know how fast the current is traveling? Well, once again, I have many equations on the page. You can pick your choice. Any equation that has a B in it and a C in it, you plug the B into any of these equations for the B, and then you can solve it for the C. So I'll let you pick. Which of these equations is the easiest to use? That one, that one, that one, that one, that one, or that one? What about that one? That looks the easiest to me. So B plus C equals 8. Couldn't get easier than, well, it could get easier, but I'm going to pick that one. And I'm going to plug in for the B, I'm going to plug in 6 because B equals 6. Ready? So 6 plus C equals 8. So what does C have to equal? 6 plus what equals 8? 6 plus 2 equals 8. So C has to equal 2. Now I was wrong actually because the boat is not traveling twice as fast as the current. The current is actually less than half of the speed of the boat. And this actually has an interesting life lesson in it, that even if the current is very, very slow, like this is actually 3 times slower than this. Even if the current is very slow, a very, very small resistance to your efforts can actually slow you down a lot. Like it took, the number of time it took was 4 hours instead of only 2 hours. So if you were driving someplace that only was supposed to take you just 2 hours to drive, and it took you 4 hours to drive there, would that be a pretty huge delay? That'd be a huge delay, right? Imagine 2 hours of being in a car traffic jam. That would be horrible. And all of that delay was caused just by a tiny little 2 mile per hour current. But since it's working against you instead of working with you, it radically slowed you down a lot, right? That's why it's always good to study math without distractions, because if you have like a little phone or something next to you and you're like writing messages and stuff like that, it's easy to do 45 minutes of that and only like 15 minutes of math, even if you tried to spend a whole hour on math. That's actually what happens to me sometimes when I'm grading. I start to grade and then the secretary knocks on the door and says that I have to do some appointments or something like that in my calendar, and then somebody else sends me an email, and then somebody else, and then pretty soon I get distracted and I just feel tired and want to sleep. And before I know it, the hour has gone by. So let's go ahead and go to number 14, because you need to actually sometimes talking about distractions is actually a distraction sometimes. So let's do 14. And it's amazing. You're going to love this one, and I think all of you are going to get a perfect score on this one. Right? My thing froze again, sorry. Oh, there we go. Okay, so 4x minus 10 is less than negative 2 times x plus 2. Let's try it. So first of all, distribute the negative 2, so you get negative 2x. And then distribute, wait, that negative 2 looks a little weird. Then distribute the negative 2 times the positive 2, and that's negative 4. Then bring down the other 4x on that side, like that. Does everybody agree with that? Now we're going to get x on the left side, so add, whoops, frozen. Come on, people. There we go. Plus 2x. I wonder if I should try, maybe I should try my phone. So 4x plus 2x is 6x, right? Minus 10. Now what do I do to get x by itself? Who has any ideas? What about adding 10 to both sides? And remember, most of the math, I think you can do it. So even if you don't feel like you're that good at algebra, you should still be able to do like probably 3/4 of the problems on the final. So put forth your best effort, no matter what. So 6x is less than 6, divide by 6, you know, x is less than 1. That's fantastic. Wow. That is fantastic. Then it says to solve it, and then it says graph the solution set on a number line. So now, by the way, on the final, I'm going to let you just write your answers like actual solutions, the way that they've done them for like the last 500 years. This book, and also recently in the last 50 years or so, they've really liked something called interval notation, because the value x less than 1 can be also represented by the interval notation that says it goes from negative infinity up to 1, right? But I feel like that's less clear than just simply saying x is less than 1, right? So I'm not going to make you have to use interval notation on the final unless I specifically tell you. But on this question, I'm just going to let you just leave it like this. You don't have to do it the way the homework makes you do it, because as long as you can solve it mathematically, that's good enough for me. But you do have to know how to graph the solution on a number line. That is still important, and it has been for hundreds of years, maybe thousands of years. So how do I graph the solution x is less than 1 on a number line? First, label the point 1. Which I label with an open dot or a closed dot. Can it actually equal 1, or can it only be less than 1? Can only be less than 1. So it can't touch 1. So put an open dot on 1. And then x can be less than 1, right? So shade the area that is less than 1, and then draw an arrow going even further left. So everything to the left of 1 is the solution. So this is called graphing the inequality on a number line. Then we're done with that. So we finished that, and that's great. You ready for number 15? Yeah. Perfect. Okay, so number 15, it says another number line. So it says negative 13 less than or equal to 3x over 4. Take away 16 less than negative 4, like that. So this particular inequality looks difficult, but it's not that difficult though. Just focus on one step at a time. So did you hear about the person who walked all the way across the whole United States? And all he had to do is just take one step at a time. So look at the bottom 4 right there. That's the first step. Look at that 4 and multiply everything by the number 4. So I'm going to circle everything with blue to show you what to do. Because blue rhymes with you, which rhymes with everything. So times 4, times 4, times 4, times, I'm going to recycle that little dot and just say times 4. Like that. So multiply everything times 4. But then make sure you cancel out the 4 in the bottom. So let me switch to red so that you can see more clearly. Boom. That 4 cancels that 4. So what we're left with is 4 times negative 13. Let me erase that actually. Does anybody know what 4 times negative 13 is? What is that? Yep, negative 52. And then 3x is by itself now. And who knows what 16 times 4 is? Is it 27, 32, 96, or 64? 64. And then what is negative 4 times 4? Negative 16. So there we go. And now we have to get x by itself. So we need to knock out the negative 64 that we have. We do that by adding 64 to all 3 sides. Now don't forget to add it to all 3 sides, because we're dealing with a problem that has 3 different sides. So negative 52 plus 64 is 12, like the 12 apostles. Negative 16 plus 64 is 48, like the 48 states. Divide by 3 on all 3 sides. And you get 12 divided by 3 is 4, like 4 years of college. 3x divided by 3 is 1x, like one class that's the best in college, which is intermediate algebra. And then 48 divided by 3 is 16. Like 16 years of school by the time you're done with college. So we've solved it. This is the solution. And this is the solution that I'm going to accept as just this. You don't have to necessarily do interval notation, although you could if you wanted to. So the solution is that 4 is less than or equal to x, and as x is also less than 16. So I'm going to put a box around that solution, and I'm going to do that on a number line because it says we have to graph this on a number line. So what do I put onto the number line? 4, and then 16. And make sure you put the smallest number first, because sometimes your inequalities end up being backwards when you solve them. Like it might say 3 is greater than x is greater than -1. So you might have the smaller number at the end of your solution. But then when you graph the solution, you still have to put the smallest number first, though. So put the 4 first, the 16 first, and then is it equal to 4 or not? Is x actually equal to 4 or not? Yes. It says 4 is less than or equal to x. So it is equal to it. So put a solid dot on the 4. Is x equal to 16 or not? No. So put an open dot on 16. It can't touch that. Like that. Then shade the part between. Boom, boom, boom. Then you go. I keep wanting to do interval notation because that's the way the book has programmed me to be. But now on the final, we can be set free from that. But just if you're curious, the interval notation would be 4, 16 bracket parentheses, which looks really weird. But the only solution, the only parts of the answer that you have to give is the actual solution to the inequality, which is 4 is less than or equal to x is less than 16, and then the number line, which is that number line. Are you ready for number 16? I think so. So let's look at number 16. And let's go back to black because easier to see. So the absolute value of x take away 2 equals 7. Ready? Now, when you solve an absolute value equation, you have to remember that the absolute value of a positive as well as a negative number would both equal to a positive 7. So if you drop the absolute value off, that splits the equation apart into 2 different equations, a +7 or a -7. In fact, you could also just say x minus 2 equals plus or minus 7. Now, one thing that I see a lot of students try to do as a mistake, though, this is why I'm not teaching you the plus or minus right now, is because if you get in the habit of just saying, just switching to a plus or minus 7 right there, for some reason, students start to change this to be a positive or negative. The value inside of the square root doesn't need to change. That's the number on the other side that it equals that can change. Okay. So x minus 2 equals 7 or x minus 2 equals -7. Then you add 2 to all 4 sides. So x equals 9, x equals -5, right? And then we've solved it. That was easy. So cool. Whoops, hold on. I don't want to accidentally write over my. By the way, one time I was grading something for another teacher, I think, and one student had written all the answers and done the work, but they had accidentally scribbled across the middle of their answer like I just did. Sometimes, like, the answer was this. Sometimes they accidentally scribbled across the middle of it like that. Well, the student who was copying their answers thought that was part of the answer. So every time the other student scribbled over something, they made the line go like exactly to the same spot. So you could tell they were just copying instead of actually thinking about the answers. I don't remember what happened after that, though. I think I just noticed that and thought it was funny. So anyway, then number 17. Ready for number 17? Number 17 says 4x minus y less than or equal to 8. And we're supposed to graph this inequality, but the difference is this inequality is not being graphed on a number line. It doesn't say number line, right? It doesn't say that. It says graph the inequality, period. So, and it has 2 variables in x and y. That means you're going to have to graph the inequality on an x-axis and a y-axis because it has an x and a y. Ready? So here's the y-axis, here's the x-axis. How do I graph that inequality? Well, now the final exam, you'll have to do this by hand with your own, you'll have a blank piece of paper, so you'll have to draw everything by hand. So how do you do it? Well, we can create a little table of points, x and y. We need to find the x-intercept and the y-intercept. So once again, remind me, how do I find the x-intercept? By plugging in 0 for y, right? So you plug in 0 for y, and if you plug in 0 for y, the y is gone. So this y is just invisible. So pretend like that y is invisible. Not sure if I can reach high enough to make it visible, but pretend like that y is gone, like that. Then you just have 4 times x equals 8. And you all, by the way, you also pretend like it's an equation as well. So if you have 4 times x equals 8, 4 times x equals 8, what does x have to equal? 4 times what equals 8? Only 4 times 2 equals 8. So x has to be 2. So the x-intercept is 2. So all I want to see from you on your problem on the final is that you plot 2 on the graph. Then, all I wanted to see from you for this part of the problem is that you plot 2 on the graph. That's not all that I want to see for the whole problem, of course. Now, how do you find the y-intercept? Plug in 0 for x. So if I plug in 0 for x, then if I plug in 0 for x, then that's 0. So the only thing left is negative y equals 8. So if negative y equals 8, then what does y have to be? If you divide both sides by a negative sign, you'll get y equals negative 8, right? So the y-intercept is negative 8. So all I need to see from you for that part is just you plot negative 8 on the y-axis. Then we're not done yet. There's still 2 more steps to do. We have to draw a line, and we have to shade the inequality. So should I draw a solid line or a dashed line for this inequality? Who remembers how to tell? Inequalities that have an equals in them are solid inequalities. Inequalities that don't have an equal sign underneath the inequality are dashed inequalities. So we're going to draw a solid line this time, like that. So draw a solid line between those 2 points. And then we have to shade the inequality, and that's the funnest part. So look at the x's and the y's. So this x is positive, and it's on the little end of the inequality, right? So the x's that are littler are the ones that should get shaded. So these x values are bigger than the inequality. These x values are littler. So we're going to shade to the left. So we're going to shade to the left. So I'm going to draw a little line pointed towards the left. I'm going to shade that direction. I'll draw another line that way. So those arrows just indicate which direction I'm going to shade. And then look at the y. The y looks like it's on the little side, but that's actually lying though. Have you ever met somebody who pretends like they're on your side, but they're just lying? Because their real sign is actually like their true colors is different. So notice the sign of that y is actually negative. That means the y itself is actually on that side. So if I move the y over to that side where it belongs, it would be positive y. So the y is actually on the big side of the equation. So you should shade the y values that are bigger than the inequality. So these values of y down there, those are the little values of y that are less than the inequality. The values of y that are above the line are big values of y that are bigger than the inequality. And you should shade those. So you should shade above the inequality. So shade above. So which direction is it if you shade both above and to the left? Then that would be diagonally that way, right? So we're going to shade everything upwards to the left of that line. And I kind of think yellow is a good color for shading. Let me go to yellow. There we go. Beautiful. So we're done with that one. And then let's go to number 18. Okay, so this says g of x equals 2x to the third minus x squared plus 5x minus 5. Says find g of 0. So this is actually kind of like going back to problem number 1. So all you have to do is plug 0 in for x, which is kind of what you had to do back in the first problem on the final. So this is a great, easy problem. So just plug in 0. It's actually even better that they said to plug in 0. So if you plug 0 cubed, that's 0. 0 times 2 is 0, so you get 0. 0 squared is 0. 5 times 0 is 0. But negative 5 is not 0. So everything is just zeros. So what's 0, 0, 0, take away 5? It's just negative 5, right? So the answer to number 18 is negative 5. That's my favorite one. Okay, ready for number 19? So question number 19 specifically says x minus 11 squared. And it specifically says that you have to multiply this using the rule for the squaring of a binomial, or for the square of a binomial. So the formula for the square of a binomial is that you always do, so I'm going to write it down at the bottom. If you have a and plus or minus b, doesn't matter which it is, I'll just say plus b, for example. The rule for squaring a binomial is that you bring the 2 down beside the a and then put the b beside it. So it's 2 times a times b. That goes in the middle. Then at the end, you square the b, so you get b squared. And then at the beginning, you square the a, so you get a squared. So that's the rule for squaring a binomial. So I'm going to do that rule for squaring a binomial. So put the 2 times the x times the negative 11 and put that in the middle of the problem. Then at the end of the problem, you're going to have negative 11 squared. At the beginning of the problem, you're going to have x squared. So what do you get if you do x squared? What's that? It's just x squared itself, right? What do you do if you do 2 times x times negative 11? What's that? That's negative Taylor Swift x, right? Because it's negative 22x. There we go. And then what's negative 11 squared? Positive 121. So the answer is x squared minus 22x plus 121. But you have to do it using the square of a binomial. You can't just do it by distributing everything out. So make sure you show your work and do a squared plus 2ab plus b squared, like that. Got it? Okay, well then number 20. Well, we've gone from 10 all the way to 20. It's pretty amazing. So here's 20, x to the third plus 3x squared. And this problem is also going to be your favorite problem of all. Wow. All it says is just factor the greatest common factor from the polynomial. Wow. When you're in college algebra, you're going to miss intermediate algebra. So what's the greatest common factor of this? You have 3 x's in the first term, and you have 2 in the second one, right? So the only part that's in common is just 2. So factor out a power of 2, of x to the power of 2. Then how many x's are left in the first term if you had 3, but you took out 2 of them? You'd only have 1 power of x left, right? And how many x's are left if you had x to the power of 2 at first, but you took out both of them? There's none. But there's the 3 still, of course. So the answer is x squared times x plus 3. That's all there is to do. That's my favorite one so far. Okay, you ready for number 21? Let's try number 21. It's probably going to get harder than that. But every problem is still worth the same. Everything is worth 4 points apiece. So 21 says x to the third minus 9x to the second plus 5x to the first minus 45x to the 0th. So if you have x to the 0th, there's just no x at all. So it's x to the third, x to the second, x to the first, and x to the 0th. And it says to factor this by what method? factor it by grouping. So grouping means you do an initial factoring. Like let's say if you cleaned your house or cleaned your dorm room as a group, then like you could clean your side and your roommate could clean their side of the room. We're going to factor this that way as well. So factor out an x squared from the first group. That leaves you with just one x left over. This is a lot like the last problem we did. And then you have a 9 left over. And then factor out something from the next group of 2, which would be a 5. And you have x minus 9 left over. Because if you divide a 5 out of a 45, you get a negative 9. Then you factor out something that's in common to that. So who sees something that's in common to those 2 different groups right now? How about x minus 9? X minus 9 is definitely in common, so factor that out. Now the groups themselves actually become part of a different group. So what's left from the first group is only an x squared, and then what's left in the second group is only the plus 5. So now the group itself has been changed into part of a new group. So you have this left. That's the answer. X minus 9 factor times x squared plus 5 factors. That's the solution. Amazing. Now we're ready for number 22, Taylor Swift. So 22 x squared minus 14x minus 32, x squared minus 14x minus 32. So who wishes you could go back and meet Taylor Swift when she was actually 22? That'd be cool. So back in those days, nobody knew she was going to be that famous. So x squared minus 14x minus 32. And what does it say? Does it say that I have to factor it? Or does it say that I have to? It says factor the trinomial or state the trinomial is prime. So can I just say prime? Well, I could if that's the right answer. Is that the right answer? That's not the right answer, I don't think. Let's think about it a little bit. No, it's not the right answer. Okay, so how do I do it since it's not prime? Who remembers the rainbow method? So we're going to just break apart the x squared itself. All we do is just take off the square and then put that into 2 different factors like that. Because obviously x times x creates x squared. So that makes sense. And then you bring down this sign. What sign is that sign? That's a negative. So bring that down. Then what do? You multiply this sign times this sign. What's a negative times a negative? It's a positive, right? So positive sign comes down. And then the next rainbow is you take this number, which is an invisible 1, multiplied by this number, which is 32. 1 times 32 is 32, right? So you try to break 32 down into parts. So 32 breaks apart into what pairs? Breaks apart into 1 times 32 or 2 times 16, but I'm going to stop right there though, because 2 times 16 actually works. How does it work? Because look in the number in the middle of the rainbow. What number is in the middle of the rainbow? Negative 14. Is there any way to get a negative 14 from a 2 and from a 16? What if I make the 16 be negative? Put it there. And what if I make the 2 be positive and put it there? Now watch what happens. Negative 16 and a positive 2 add up to make a negative 14. Oh, so it works perfectly. So I'm done factoring it, and that's the answer. Now I'm feeling 22. Fantastic. Okay, I want to ask you a question. Who would like to do a couple more questions so that you can maybe get it done across a little bit early on Friday? Okay, so let's just do, I don't want to rush in more than we can because I don't want to lose the quality just in favor of quantity. But let's maybe try the Michael Jordan problem next. So number 23 says, oops, I wrote the 1, sorry. 23 says 3x to the 2 plus 6x minus 45. 3x to the 2 plus 6x, 3x 50 plus 6x minus 45. There we go. And we're supposed to factor it. Oh, yikes. I wish that instead of writing factor it completely, I wish they would just write go to Brahms and have a banana split. What if that's what your test question says? So I need to factor out something that's in common first. Is there anything in common to this problem? Other than that we don't like it? There's a 3 in common, right? So factor out a 3. We have x squared plus 2x, take away 15. There we go. Now we have to do the rainbow method. So the part that's inside the parentheses needs to be broken apart by taking away the squared from the x, this breaking the x squared apart into x times x. And then this sign right there, that sign comes down, plus, and then you multiply this sign times this sign, positive times negative is a negative. And then you have to be really careful. That 3 is now outside the problem for us. You don't look at that 3. The number you look at with the rainbow method is the number that's still part of the problem, which is the 1 right there. So there's an invisible 1 in front of the x squared. And you multiply that 1 times that 15, and that's 15. So what is wrong with this? Okay, 15. And so you break 15 apart into 1 times 15 or 3 times 5. And I'm going to go 3 and 5. Because if I use a positive 5 and a negative 3, then positive 5 plus negative 3 equals 2, which is in the middle of the rainbow, which is what I need. So that's good. And this is as far as it goes. So the final answer is just that. 3 times x plus 5 times x minus 3. I don't know why I wrote it again, but I just wasted part of my life, but that's the answer though. So that's probably a good stopping point. And then on the next class, I'll do the last 11 questions. Yes. These problems are posted inside of Moodle. Right here at the top where it says important. Then you click on the link right above that, click on that link, and then you can download those problems from there.
And then the videos are
Yes, and I'll post the videos as well. Right, yeah. I'll post the videos right underneath that same section. You're welcome. Oh, and wait. I didn't do attendance yet, so could you just write your name down real quick? Does anybody have a pen? Actually, here go, Lou. Can I just make a voice memo? And you're going to say your name. Okay, ready? So say your name.
Chris Atkinson.
Then you can go.
Sean Davis. Carlos. That was us. Mason White.
Madison True. Just.
What we have to say in the phone?
You just have to say your name into this for attendance.
Perfect.
And then you're going to say your name too.
Hi there, go. Perfect. So we're doing each next.